for our problem, we had example 1C2, and in that, here's the given. Pin P is constrained to move in the slotted guides that move at right angles to one another. At the instant shown, guide A moves to the right with a speed of VA, a speed that is changing at a rate of V dot A, and at the same time, B is moving downward with a speed of VB with a rate of change of speed of V dot B. And we are instructed to find A, the rate of change of speed of P at this instant, and B, the radius of curvature rho of the path followed by P at this instant.
All right, so to kind of reiterate what he said, first we're gonna find V dot of P, and then we're gonna find rho. So, and then like he was saying, we're given a few things, we're given these parameters right here. We determined that we were gonna be in the Cartesian coordinate system. So VA having going in the right direction, we're gonna say is the I hat direction. So VA is given to us as 0.2 meters per second, and that one's gonna be in the I hat direction. VB having traveling downwards is gonna be in the negative J hat direction at 0.15 meters per second. V dot A was given to us as 0.75 meters per second squared, and that one's gonna be in the I hat direction as well. V dot B was given to us as 0 meters per second squared. So now to jump into our solution. So first thing that we decided to do was to find ET hat, and the formula for that's gonna be ET hat equals VA I hat plus VB J hat over the magnitude of the velocity vector. Then to find the velocity, the magnitude of that velocity vector, you're gonna take the square root of VA squared plus VB squared. So when you plug in those numbers, you end up with the magnitude of the velocity vector is equal to the square root of 0.2 squared plus 0.15 squared. And then that is going to be equal to 0.25 meters per second. So back to our formula for ET hat. Once you plug in the numbers for this one, you end up with 0.2 I hat subtract 0.15 J hat over 0.25 for our magnitude. And then that ends up equaling ET hat is equal to 0.8 I hat subtract 0.6 J hat. So then we needed to define our acceleration vector. And since we're only given one acceleration, one rate of change of speed being V dot A right here at 0.75 I hat meters per second squared, our acceleration vector is only going to be 0.75 meters per second squared in the I hat direction, nothing in the J hat direction. So now we can finally plug all that into the equation. V dot is equal to ET hat dotted with the acceleration vector. And then once you plug in your numbers there, you end up with 0.8 I hat subtract 0.6 J hat. That's going to be dotted with 0.75 I hat subtract 0 J hat. And then the meters on this are going to be meters per second. So after you plug everything in there and you do your math, you end up with V dot equals 0.6 I hat meters per second. Perfect. And then for the second part of our problem, we were to find rho. To find rho, we were going to use the equation, the magnitude of the acceleration vector squared is equal to V dot squared plus V squared over rho all squared. So once you simplify that equation, you end up with rho is equal to V squared over the square root of the acceleration vector squared subtract v dot squared. And plugging in your values, you end up with rho is equal to 0.25 squared over the square root of 0.75 squared, subtract 0.6 squared. And again, after you do your math there, you're gonna end up with 0.139 meters for rho.
Alright, and that is how you solve example 1C2.